Good afternoon. I'd like to do my presentation during multi-agent simulation. And in this section, I explain the multi-agent simulations by developing the very simple model written in NetRobo. This slide is about NetRobo. Today, I skipped this slide. And in this slide, I introduced the simple model, shopper's world. This model expresses the people to shop in the mall. In this model, shoppers and shops are defined as object. 10 shoppers and 12 shops are set up randomly to the world in this model. Shops has
shopper means customer of there.
So customer テキストではショッパーっていうふうなことを and shops has like information, two informations and each shop location and product which they sell. Shoppers and customer agent do shopping with shopping list, which records the product, 10 products which they sell, which they want. And, in this model, shoppers search and move to the shop randomly in the basic model. And in this simulation, when all agents have finished their each shoppings, this simulation will end. In this simulation, we will observe the simulation tick, how long it takes for them to complete the shoppings. And I will make agent more complicated. How the simulation tick will change. Please look the basic simulation model. Basic model and customers and shops are set up randomly, and the customer search and move to the shops and randomly and do their shoppings. あ、消えた。もちろんですね。This animation is so long. I skip this animation. all agents finished their shoppings. Simulation peak is 15,674, and in this simulation, the customer search the shop randomly and have visited the same shop twice and 3 times. And so in this simulation model, customer is so stupid. It was so stupid, and the simulation tip is so long. Then in next slide, I would like to give the agent, give the ability, intelligence to the agent. And as the first step, we will give the agent the ability to memorize the information about shop, and the information about shop are the product which they sell and each shop location. And by this ability, agent can move to the closest shop and never go to the same shop. This is the second simulation. I skip this simulation. All customers have finished their shoppings, and simulation peak is 11,461, and peak got more short. And the last step, we will give the agent the ability to exchange information to other agents. And for example, agent A and agent B has each information about shop. And if agent encountered the other agent, and they talk about the shop they have entered, and foreign agent the copy other agent has information, and on the other hand agent B copies agent A's information, and by this ability foreign information expand the all agent, and all agent got more intelligent. This is the third simulation model. In this model, all agents sharing the information about the shop. This agent is stupid.
Maybe he has a very rare product to buy and he has to search. Maybe there's only one shop that has
情報を交換できないかっていう。
ああ、
そのエージェントが情報を共有したわけではなくて、変換ポイントしたわけでは
そうだ、出会ったらカウントするんですけど、最終的には残ってるからですね。This simulation is 4,186. This is so short. In this section, as a conclusion, by incrementing the intelligence to the agent, simulation team got shorter. And like this simulation, and we can make the multi-agent model more realistic by implementing the intelligence, and we may enable to get the model close to the human society, but it is not necessary. For building the multi-agent simulation, important thing is to develop the model so that useful and illuminating simulation of human societies can be constructed. Its conclusion. I finished my presentation. Thank you. Any other question or comment?
Okay, I want to start my presentation about sugar scale models. And I use some あ、そう。できない。
1で1でですね。
Okay, I want to start my presentation about sugar scale models. This sugar scale model is simulate virtual ant society. This society ants eat sugar to survive, and each ant having some application to searching sugars. In this simulation, describe various social aspects like by recognizing environment, describe his action. But it's not meaning some communication. Communication meaning agent to communicate. But in this simulation, it's not communication. It's only passive environment. And a strongly skewed Wells distribution soon develops. First, in this graph, such flat Wells having and population, but it's extreme example. In this maybe this such graph is real one. This symmetrical Wells havings, but running simulation, then such skewed like a human society is. In such aspect is describes in simulation.
What Wells mean?
Wells is amount of sugar. It's about to some agent havings.
Sugar, eat sugar many times, then get rich.
Yeah.
Okay.
So the Wells meaning the amount of sugar. Well, I want to account of rules. Ants move to horizon or vertical parcels to seek the rich sugar area, but consume if they move. In this area is not flatly sugar distribution. So sugar searching the rich sugar area, but ants can move vertically and horizon and vertically. It's normal neighborhood concepts, and to seek rich sugar, but consume if they move sugar, but not moving, they also using sugar energy.
I have a question. To move, if they move, they consume more sugar.
Yeah.
Okay.
So and each ant having each visual, but visual power is not equal. This sugar only one neighborhood sites, but this ants having three, and it also can see so such and more. If this area having some 2-point sugar, but he cannot sing, so he cannot move. He also cannot sing, so he cannot move. ants dies if there is no sugar or stock or natural dye. And if ants die, new ants replace the dead one with randomly area. And if ants have some save his sugar, if he's hungry, ants save his sugar. Sorry. And this is the important. Sugar is generated each steps, but generating speed is not same each cells. But this cells is 11000. But this area is one time steps increase one sugar, but this area is cells one time steps increasing one, but this area is 0, but two increase, but this area is not increase. Such different increasing speed. So now I want to in net logo, there is a sugarscape model. So such area is rich sugar, and this area is no sugar. And such the red one is ants. Ants having some sites, but it's not equally. So now I want to do the one steps. Such area ants died because they cannot eat sugar. But this rich sugar area, the ants live. Such ants, this area ants is okay, but these ants cannot see where is the sugar. So maybe that sugar is there, such model. So such this is. So in sugarscape model describes various ants social aspects, and the one is moving reaches with negotiation. And in this only sugar model is not negotiation. This is additional factor of spice to living eating ants like a sugar. If such is rich sugar area, and this area is rich spice area. So so these ants maybe can eat spice more, but not smaller little sugar. This is also, but it can eat much sugar, but it's less spice. So this agent can, by the negotiation, exchange. In this extended model, it can describe such moving of riches and distribution of riches. First, symmetrical distribution to go to like a human societies which is distribution and social network. In this cascade model, can accounts agent is more intellectual, but simple agents such as ant action. Next example is the evaluation of organization society. This model is describe organization in Stone Age, like first Stone Age people living such a isolated house, but making society such making some village. So in these steps, simulation, and so using simulation to explore theories which account for the growth of social complex in the Stone Age. In the characteristics of EOS, more wisely agent, sugarscape model having some little intellectual, but in this EOS observation recognize very planning decision, as like Mr. Ozaki said, accounting factor is having. So making more complexity as like a human society, and more organizing agents. To gathering resource, agents make an organization. If this point is this dot is resource, such resource is rich and described widely. Agent action, agent gathering research solo is more effective, but resource is such not sprinkled agents gathering agent can gathering resources organize than solo act. So in this is characteristics of EOS. In this model, agents intellectualize agents. So such describe such complexity model can describe. So the summary of chapter 8, Mr. Ozaki accounting about property of agent with knowledge graph, goal planning language, etc. And Mr. Ota accounting about building multi-agent simulation by the implementing intelligence more polished simulation. And my accounting about sugarscape model, simulate and society, describe and social aspects, but this model is suggest is hard task to make agents. So next chapter, group 4 will account about suggesting for making the design of multi-agent model easier. So that's all.
Any questions?
Yes.
Thank you for your presentation. Next is group 4. Group 4 flavor is
Good afternoon, everyone. So, our group is chapter 9 and chapter 10. The members are me and Kazumi Isawa and Mr. Wan. First, I start chapter 9. The title is Developing Multi-Agent Systems. Let's start. This is chapter 9 outline. First, I explain what we should do before designing the model, and what is the designing process of model, and what is unit test and debugging, and multi-agent simulation and stakeholders. In the last, I explain the conclusion. First, I explain what we should do before designing a model. It is essential to think your research question to make a model. What is research question? Research question has 3 layers. These are 3 layers. First one is general research question. And second one is specific research question. Third one is data questions. Before making the model, you have to think these research questions. I explain this research question in the next slide. Before designing the model, we have to think the layers of research questions. First one is general research question. General research question is a general interest in the topic. And this general research question generates a small number of specific research questions. So this general research question generates specific research questions. So what is specific research questions? Specific research questions is at the level of details such that their concept can be used as the main elements of the model. And in the next level, data questions. Data question means what did you want to obtain from research. So in the image, the general question is more large idea. Specific research question is generated from this general research question. So there are some specific research questions. And data question is more specific than specific research question. What data you want to obtain from the research? This is the data level. Is it clear?
I have questions.
Hi.
Well, the data you want to obtain from researchers mean that you do the research,
Yeah.
get the results, and you get the new data, or based on the data, do the research and compare the data. Which one?
You say output or input.
Yes.
So this is in the article. There is some sentence about that. One example. So if you want, so I'll show one example for the explanation of research question. And you want to know in textbook, the author show one example. There is 2 groups, like supporter of football team A and football team B, and these groups may conflict. But these groups are not may conflict. So general research question is, what is the relation between the groups and chance of conflict? At the specific level of research question, you want to know there are of course some person like ぽい人とか普通の人とか。And the specific research question is, what is the relation between the several members and the chance of the conflict? And data question. Data question is how different the occurrence probability, occurrence likelihood when they are interact, the groups are interact. Data question. In this case, you want to know the conflict probability from the from this research.
So it's the output.
So in this example, we can say that is its output. So and because designing models, should the model be simple or complex? The social world is very complex or very complicated. But the art of modeling is to simplify as much as possible, but not oversimplify to the point where the interesting characteristics of the phenomenon are lost. The most effective strategy to modeling is to start from simple model, which is also called baseline model. So if you can understand the behavior of a simple model, you develop a simple model to extend the model. And when you develop simple model to extend the model, it is important to pay attention to research question, your research question. Okay. Before designing model, one should look around for existing theory. Theories concerning the dynamics of social phenomena are better than theories about equilibria and static relation. But any theory is better than none. And why you should look around existing theory? Because there are the laws of theories. First one is you may know relevant features that need to be modeled by the theory. Second one is you can identify the assumption on which the model is built. Note that you should articulate the assumption of model clearly. If articulate the assumption, you have to say the assumption of the model clearly when you are making the model. Okay. So, if one specifies research question, existing theories and assumptions, you can start designing a model. And from here, let's see the designing process. Is it okay? This is design process 1. First step is to define the types of objects to be included in the simulation. So, it is useful to do this first step by using a class hierarchy. Class hierarchy is this image. This is object, or we can say this is class, and it is easy to see what differs between agent and what is the same. So, object or class will be agent, which representing the individuals or organization. But we can use this agent as non-animal, like input or obstacle. So this is class hierarchy. Okay.
So can you return to previous the previous one more. Sorry. Yes. Well, I think in the design model design step, this stands for the boundary setting. That means that you can build a simple model or a standard model, but you have to set the boundary for the model. That means you cannot make it too simple or too complex. Depends on your research questions. And I think the data questions is not the output, but the input of the model. So based on the research questions, what is the available data, the data that we can collect to implement in the model? Because we haven't built the model, so we cannot know the output, right?
Yes. So data question is input.
Yeah. I think it's the input to the model, and maybe output is mean the expected results, expected data that can be observed, can be obtained from research. And the next slide, please. We should look around for existing theory. This process, I think, is the theoretical investigation. That means we have to check about exist theory, and we can find, we can suggest some, assumption, some hypothesis, and to check the hypothesis when we have done the research. So this is my opinion. I think the data question is that we should find, we should investigate, we should research that the data for the model is available or not. So we can, based on the available data, we change the boundary settings, change the hypothesis, and change the model. I think it's the input, not the expected output.
Yes.
I have a similar opinion with Mr. Green, that first when we are building models, we have to confirm that what kind of data that we can get, and based on this kind of condition, we will build our model. And in another case is that we finish the model and run the simulation and get some results. And our research must have a kind of concrete topic, and we will analyze these results to import our research topic and to find the final answer to our research. So perhaps the data is very important.
Yes. So the data question is like the input. So you say what we can get in the before the modeling.
I think there are two aspects. First one is that what can we get, and the second one is that what we're expecting to get. So there are two aspects.
Yeah.
So maybe in the second case, it's not data.
Yes.
It is the output. When you say data, most of the time it refers to the input. But I think in this case, it should refer to the output. So maybe you should not use the word data. maybe some expected output as Gwen said. Yeah, because from this logic, it's more natural to think it refers to the output. It's only you use the word data, so it's kind of confused.
Just like Mr. Green's research, you get the node and you run the simulation, and you get the data of the spread of the disease, right? And you based on this data and get the results of the research.
So in fact, this is the first stage of the of my research methodology, and I think the data is the available.
Yeah. Here, because data actually most of the time refers to the input. But when you say the output, we do use data. We just use output. So the word itself is a little bit confused.
So yeah, actually in the textbook, word by word, maybe they want to say about outputs.
Yeah, that's right.
It's a little difficult to understand because maybe it depends on the research itself. But anyway,
yeah, that's right.
well, a little strange.
Yeah, but I didn't find data question in the textbook. Is it in the textbook?
Chapter 9.
Yeah.
You can find
Page number
201. First paragraph, last sentence. Finally, there are data questions that the model will answer with proportional.
I think it refers to the output here.
So a little
Yeah,
confusing.
a little confused. Just try to overlook it. So I have another thing about this theoretical investigation. Sometimes there's no theory.
Sometimes, yes.
There's no theory.
For example.
Or perhaps
Like in my research in e-government, of course there are many theories, but most of the work based on theory is not simulation. It's kind of the way they make some theory. But for all the simulation they just do the simulation. They have their own hypothesis, but not theory. Right.
Maybe because the theory is not
haven't been established.
doesn't exist.
It's kind of when we build model theories that important. I believe it is important, but sometimes I find most of the papers do not have theoretical framework.
Well, we will discuss about it.
Yeah.
So I continue the next slide. So first step is to define the types of objects to be included in the simulation. And this is class hierarchy. Then process 2. The second step is to consider the attributes of each object. An attribute is a characteristic or a feature of the object. An attribute might consist of a single one of a set of values. For example, this is the energy level of agent. And in other cases, an attribute might consist of a little list of values. For example, it is a list of the names of all other agents. The subtypes inherit the attribute of their types. For example, if all objects have a location, all subtypes have a location as an attribute. I explained this in the class hierarchy. So if this object has attribute of location, the subclasses are agent type 1, agent type 2, and these have a location because they inherit the attribute of this object. attribute can be shown on the class hierarchy, like this. This design method is called Unified Modeling Language. This method is often used in object-oriented programming. So we can write the attribute in each class hierarchies classes. Okay. The third step is to specify environment. There are two types of environment. One is spatial environment. Each object has a location within it. Second type is new network between agents. Network means link between agents. So when you define the network between agents, you define another object and specify its attributes. Okay. On design process 4, if you finished defining the class, attributes, and the environment, you can start to add dynamics. And if you finish this process, this step has been static design. So you have to add dynamics for the modeling. So design process 4 is adding dynamics. First, you think agents act on environment. Of course, environment also acts on agent, so there is interaction between agent and environment. In the same, we can think agent acts on other agent, and other agent or other agents acts on one agent. So there are interaction between agents. You think these interactions. Of course, you realize that additional attributes are needed for agent or environment. You can return initial step. Initial step means the previous steps, like process 1 or step 2 or step 1. You can add attributes if you need it. And when adding dynamics, a sequence diagram and a statement and activity diagram are helpful to summarize the dynamics. What is this? First, what is sequence diagram? Sequence, you can see this part. This is sequence diagram. This particular line is time, and this is agent. You can see the agent in this place, and you can see this is action. This agent act on this to this agent. This is action of agent. You cannot see this part. In this part, there are the condition of action. Also, agent action needed to be associated with conditions. 消えちゃったんですけど。There is condition. これはアクション。So there are conditions of agent action in this place. This is sequence diagram. a sequence diagram. This is agent, and this is condition. This is not activity diagram, statement diagram. And this is action. And next, I'll explain statement activity diagram. なんかこれがこのスライドがなくなっちゃった。Statement and activity diagram is like this image is statement and activity diagram. This square is statement diagram. Statement diagram shows the state of agent. And this figure shows activity diagram. Activity diagram shows the how decisions are made by the agent. So decision is this. Here is decision, so this part is separated to two parts, state. So this is useful to add dynamics. Okay.
Please. Can you explain the chat mean in real world manner?
Real world?
Real world manner. What this mean?
This one?
No.
This one?
Aggression. If aggression
Ah.
is larger than 25, then attack.
So if this
on the previous one. Yeah. Activity diagram. Crowd participation.
Participants.
This is what is this example?
Yes.
This example is the crowd. This is dynamics of this model. So if one agent attack to another agent,するかどうかを表した条件ですの行動。
2つの集団が衝突するときに、
Aggression というのは属性
Yes, this one is attribute.
attribute.
So if the attribute of this agent aggregation is larger than 25, this agent will attack to this agent. Only set aggregation to 0. It's okay?
Well, if agent is very hot, then attack, and after
Yes.
100 time
After time,
collapse.
set aggregation to 0.
A become calm.
They become calm. Is it okay? Let's go to the next slide. This is sub-design process, cognitive models. Cognitive models describes how the agent reacts when presented with stimuli from the environment. So, cognitive models is useful to design the psychological or cognitive models. If research question needs human cognition works, cognitive models which are well supported by psychological data can be used in simulation. And if you want to know more about cognitive models, please see SOA and actual model. So you can see in this. And the advantage of cognitive model is they are based on decades of cognitive science research on human performance. We can make agent behavior correspond to the behavior of human through the cognitive models. And let's go to next step. One design process is user interface. To design the user interface. There are two types of user interface. First one is components for input of parameters. Second one is graphs and display for output. There are some notation for this interface. First one is interface or for input. Initially, it is best for simplicity to use the minimum of input controls. And if you understand this simple behavior, you add some input, some parameter to the parameters. And the notation of interface for output is, if output displays are not required to answer the research question, they can be removed. So this is all for a design process. The next topic is unit test. The idea of unit test is to write code of unit test in parallel with small piece of these codes. And for each code, we write the unit test. And for this piece of code, we write unit test. And every time the program is modified, all the unit tests are rerun to show that the change has not introduced bugs into existing codes. Is it okay? Unit test. On the next slide. Debugging. About debugging. It is impossible to avoid bugs. The most important strategy for finding bugs is the method of test case, using the test case. So, what is a test case? So, you separate the program to the test case, and you can obtain some output from test case 1. And on the other hand, you know the data, expected results for the test case 1. For each case, you can get output test case 1, and you know the expected result for test case 2. And for reducing bugs, you run these test cases until all test cases yield the expected result. This is the process of using test cases for debugging. Is it okay?
whole program. But the previous slide is part program. Part program. And
So,
it's different.
I think these two methods are different. But they are 似てるアイディアだ。Is it okay?
Oh, this is it not a unit test? Whole test?
This is, I think the idea of unit test and using test case is near idea, but in this article, these two methods are separated. I think this unit test is focused on the correct move of program. In this using test case, you compare the output and the expected output in the part of the program. So I think that is the difference between two methods.
So maybe this, the word of bugs, meaning unexpected result.
Yes. Unexpected result. If you find the unexpected result, you check these test cases. The most thorough way of verifying the model is to implement the model by using different programming language. So what is verifying? Verifying is to ensure that the output does reflect the underlying model. You can see the verifying in chapter 2. For example, you can obtain the same result between different programming language like C++ and NetRobo. You can say the model is verified. After the debugging and verifying, you have to validate the program. The validation is written in chapter 2. Next, multi-agent simulation and stakeholders. There are stakeholders who are interested in the simulation because they hope to run the result. To have stakeholders involved with simulation research has 4 advantages. First, one can be more confident with the research question. Second, stakeholders are likely to feel some obligation to respond to research. Third, stakeholders have a rich knowledge about the phenomenon being modeled. Fourth, stakeholders' involvement can raise their interest about the issues. This is 4 advantages. In conclusion, in this chapter, I have described a process for designing multi-agent model. It is most important and difficult part to connect research questions and designing the model. That's all on my part, chapter 9. Okay.
Okay, good afternoon everyone, and I try to I have introduced the chapter 10 learning and evolution models. And
ちゃんと消しますね。
Please clean up your whiteboard.
First of all, this chapter is about learning and evolutionary models, and what's the difference between the ordinary models. I think the previous chapter, all of the models remain unchanged during the course of the simulation. That means the parameter is constant. And in this chapter, we'd like to introduce the model that incorporates with in learning. And first, as the examples, example first of all is the simulation runs. Parameter can change, and another one is the model itself will change during the course of the simulation. And this kind of learning models is mostly based on the research of machine learning and optimization problem. And this kind of overall of the chapter. And the most widely used approaches in social simulation is divided into categories. The first one is the artificial neural network, and another one is the model based on evolutionary programming. And I will mainly introduce the contents about artificial neural network, and Mr. Yakizawa will have a detailed introduce about the evolutionary programming. And first, about the artificial neural network, and this kind of model is based on analogies from biology. And as you know, just showed in the picture, our brain is composed of thousands of billions of cells that are called neurons. And just like here is the neurons, and these neurons, many neurons are connected by the kind of rods, and the electrochemical impulse will be delivered along the connections. And each neuron can obtain input from a number of other neurons by the connection. And if a neuron receives inputs of sufficient strength, and it will fire and output pass to another neurons. Just here is the red one. Perhaps this is the fire that this neuron generated and delivered to another neuron. And in generally, there are about 100 million neurons in human brain. And what about learning? Learning usually, in this process, learning usually happens when two neurons fire at the same time, and strengthening the connection. The connection among this is connection. The connection among the neurons, and we reinforce that the neuron in the particular way. This is the process of learning, and as the method of artificial neural network is based a kind of simplification of the biology process in the brain. However, as for the number of the neurons, and in the typical artificial neural network, usually more than 15, but in the typical human brain, there is about 1 million neurons. Although the number of the neurons are different, these two kinds of system works in the similar way. And another one, usually used in social simulation, is about the evolutionary competition. I'd like to have a brief introduce about this kind of methodology. And do you know the concept of evolution in the natural? The first suggests we image a large population of rabbits, and here is the shows the action of the rabbits. They breed, they produce baby rabbits, and they die. And at the same time, there are many outside, or you say environmental factors. Perhaps the environment is quite bad, and there are predators that eat them, and also the limited food supplies. We have a kind of negative effect of the rabbit population, and also there are diseases in the population. And we will assume that the rabbits with large ears, just in the picture, that rabbit with large ears are filled with this kind of bad environment, and it's more possible for this kind of rabbits with big eyes, big ears to reproduce than those the rabbits with smaller ears. And the baby rabbits, or you say the offspring, depends on the combination of the parents' genes. And it's quite natural and for us to figure that gradually the population will reproduce itself, and the number of the rabbits with big ears will keep increasing. And this is the concept of the evolution. That those individuals which are more can adapt to the environment will have a big population. However, in this kind of learning process, the population take as the whole that can be considered to be learned how to adapt to the environment. But as in the individual level, they do not have any effects, any knowledge of this fact. So this is a kind of concept of the evolution and some characteristic of evolution. And as typical methodology, or using method, is that based on the natural selection, we developed a kind of algorithm with similar mechanics that is famous as genetic algorithms. And this kind of method has the same mechanics with the natural selection process, and is extremely useful for finding optimal solutions to complex systems. And here is a very typical application of the genetic algorithm. This is traveling salesman problem, and the problem is defined as following. First, a wholesaler wants to plan the route of a delivery van so that it can visit a number of shops, and the route needs to be minimized to the a rather small distance. And just like this is the picture, the red point is the shops, and the blue line is the route. And we will use, and our objective is to minimize the distance of the whole route. So in this kind of problem, we use genetic algorithm to solve this kind of problem. And this is the concrete steps. First, we simulate multiple copies of the delivery van and give each van a route generated at random. This kind of route, initial route, is generated at random. And secondly, we will access all the roads based on the total distance and delete the long roads. And finally, we will generate some new roads based on the maxing the previous roads, then this kind of new roads will be consisted of the parts of their parents' roads, and we will repeat this kind of process to generate a rather optimized solution of the traveling salesman problem. And here, next, I'd like to introduce the artificial neural networks. And this picture shows a typical structure of the artificial neural network. And the left, usually there are three kinds of layers. And the left side is the input layer, and the middle side is the hidden layer, and right side is the output layers. And each layer had many units, and there were many connections among the units in different layers. And firstly, I'd like to introduce a terminology which is called activation, and this means the strength of the output from the units. And for example, this line is measure output of the of this unit. So the strength of this output will be called the activation. And usually, first, how does this kind of system work? First, we have inputs. We have a lot of inputs, which will be delivered to the input layers, which there are many kinds of input units. And this input will be processed by the connection between the units among input layer and hidden layers. And secondly, after the inputs are processed by the connection between hidden layer and input layer, the inputs will arrive in the hidden units in the hidden layer, and consistently the inputs will be produced by another connection between output units and the hidden units. And the output of the output units is the response of the whole network. And this picture shows the detail of the artificial networks. First of all, this is a unit of in the network, and we have two inputs, input 1, input 2, and this input will be processed by the connection, and resulting in activation and to be sent to the next unit. And usually the action, or you say the inputs will be produced in this way. That is, first we multiply each input with the weights of the connection, and rescale the weights into a value from 0 to 1. And usually we use this kind of function to rescale the activation. And we'd like to introduce the concrete application of the neural network. Image, this is a matrix which have 36 units, and it's kind of a handwriting recognition system. And you draw 9 in this way. And for each unit, if there are ink in the unit, the inputs will be 1. If there are no ink, the inputs will be 0. For example, there is no ink in this unit, so it is 0, and there is a kind of link in this unit, so it is 1. And would be the artificial network, neural network in this way. First of all, because we have 36 units in the input panel, so we have input layer with 36 units, and this there is connection with the hidden layer with 4 units, and this hidden layer will be connected with the output layer with 10 units, and because usually and the input signal will be processed by this neural network, and will get the results of the handwritten recognition. However, this is just a kind of image of the system. The details is quite a little bit complex. For example, as the application, we assumed that the network is already trained to give the right output for a given input. And this actually the training involves the training process is quite important and complex, and the main issue of the training is to adjust the weights on the connections. And the typical method is the back propagation of the error. And this is a complex mechanical process, and to train a network, first we need a large number of the training data and examples of the patterns that the network is intended to recognize the correct input. And firstly, we start with the weights randomly assigned to the connections in the network, and secondly, we give the training data to the network, and the weights by the training data, the weights of the connections will be automatically adjusted to generate the correct output of the network. And here we'd like to introduce another interesting application of the artificial network in social simulation. And here is our research question. That first, there is a group of agents without a shared lexicon with who wish to communicate. And how these kind of agents develop a common language from nothing, without any external agency teaching them the word their means. And this is our research question. And here, and the research generates artificial neural network for each agent. This is the image of the agent, the artificial neural network for the agent. Here you can see there are one input layer, one output layer, and two hidden layer. And the input layer include encoding of the visual scenes. So what means of encoding of the visual scenes? Such as one agent observes a scene like this, but they do not know the name of this thing, and perhaps they generate a name of this thing as a pen. That means encoding of the visual scenes. And the output layer is designed to generate the word to communication with other agents. And in this research, we have 4 agents. And this picture shows the state of 4 agents after having learned the known axiom, and you can see the picture. These 4 pictures is very similar. So this experience resulting that each agent can adapt the same symbol from nothing. So this is the results of research, and shows that the agent has the ability to generate a common dictionary from nothing. And next, we'd like to discuss some issues in designing an artificial neural network. And in general, there are 4 aspects. The first one is the way in which the inputs are encoded, and second one is the number of the hidden layers, just as the previous research. In this case, we have 2 hidden layers. And the third one is the number of the units in each layer. And this last one is that the way in which the error is calculated. We calculate the error to adjust the weights of the connections. So this one is also very important. And as the data coding, we usually follow the following principles. First, as the continuous values, we will rescale to the value to fall into between 0 and 1, and then input them directly. And second one, if the input data kind of categories, we'd like to code it by them assign one input unit to each possible category. And if the input data kind of features, we'd like to code in the binary units that are assigned to each binary position. This is the basic principle for us to design to decide the method that we use in data encoding. And as for how to decide the number of units in each layer, and it's quite easy for us to decide the number of the input and output layers. So we just set the number of the units, the same of the data we use. Just in this case, here we have 36 units in the panel, so we have 36 units in the input layer. And as the method for us to decide the number of the units in individual is rather a complex one, and a number of the rules and of the sub and the estimation procedure has been developed to give kind of rather rules guidance, but it's still very difficult. And a simple principle that we'd like to follow is that as the number of the hidden units is increased, the accuracy of the input recognition will increase. But however, the capacity for the generalization will decrease. So there is a trade-off between the accuracy of the input recognition and the capacity for generalization. So we have to consider this kind of trade-off very carefully. And the next one is the mirroring error. And this is also very important for us to adjust the weights of the connections. And usually there are two kinds of methods. And first one is we just calculate the difference between the output and the target label. And we'd like to calculate this kind of error for each separated output unit. There is another method that we calculate the square roots of the sum of the squared errors from each output to access the overall success of the network in recognizing inputs. So the second one is used to assess the whole network, and the first one is used to assess the individual units. And this is the part of the artificial neural network. Okay, thank you. Do you have any questions?
Next, I'd like to introduce about evolutionary computation. Evolutionary computation is also based on a biological analogy, drawing on the theory of evolution by natural selection. Evolutionary computation can be used for black box that aim to find optimal solution to complex problems, and genetic algorithms as models of evolving social processes. biological metaphor, the important points are it is the population as a whole that evolves, not the individuals. Evolution can only work while diversity exists in the population. While species are adapting through evolution to the environment, that environment may itself be changing as a result of the activity of the population itself. And skills or other attributes that individuals acquire during their lifetime are not passed on to their offspring. About the genetic algorithm. Genetic algorithms takes the essential aspect of this picture of biological evolution and represent them as computer models. And each individual has some measurable degree of fitness. One area where GAs have been used is in modeling rational action. Social scientists and especially game theorists have investigated the conditions under which rational actors will engage in cooperation. The prisoner's dilemma is a standard scenario used by social scientists to investigate collaboration and cooperation. Axelrod used a GA to evolve a good strategy for this. And the story of prisoner's dilemma is that two prisoners are held in separate cells. And each prisoner is asked independently to betray the other. If only one prisoner agrees, this prisoner is rewarded, and the other is punished. And if both prisoners defect, both receive moderate reward. If both prisoners defect. And both prisoners cooperate, they give reward. And in many situations, the choice is not made once, but again and again. Maybe it is some trouble. In genetic algorithm, prisoner's dilemma is described as this. Each agent determines their next move, cooperate or effect on the basis of the outcomes of its previous three games. Cooperate, CD, DC or DD. Represent each player's strategy as a chromosome. And use crossover and mutation. Figure is not a pair correctly. So, excuse me. Sorry. This is the prisoner's dilemma's payoff matrix here. まあ、プレイヤー A、プレイヤー B、コーポレート、ディフェクト。If both players cooperate, they receive 3 points. If player A cooperate and player D defect, player A receive 0 point and B receive 5 point. In this case, A receive 5 and B receive 0 and 1 if both players defect. And it is a figure that the evolutionary computation algorithm first generate n individuals with random genes. First, and then here compute individual and population average fit. Population average fitness. And next, breed new population by crossover and copying. Then mutate a small population of the genes of the new population and loop this. This is the evolutionary computation algorithm. The genetic algorithm evolves a population to optimize some fitness measure. The measure used depends on what is being modeled. And for example, fitness is determined as wealth or happiness, like that, and so on. And next, selection mechanisms. The reason why the genetic algorithm optimizes is that breeding is carried out from the fitter individuals. Commonest and simplest is tournament selection. Pair of individuals are picked up randomly, and the one with the higher fitness is used as the parents. And the other parents is also this, through this. And next topic is genetic operators. I explain about crossover and mutation. The most important genetic operator is crossover. The process of taking two chromosomes, snipping, the process of taking two chromosomes and snipping them both at same randomly chosen position. And then choosing one end from each. And here. And mutation makes the
It's meaning the choice of the best one in chromosomes.
Random.
Random.
You mean the where cut?
Where cut place.
It's
Well,
randomly.
Random.
Randomly chosen position. And mutation is randomly changing a very small proportion of the seeds to this or vice versa. So if I explain here 1 or 0, and if chromosome has this data, mutation makes that with a very small probability makes the 1 point change randomly. But it is a very small, probability. This is the figure of crossover. And offspring is great. Although biological evolution typically takes place with millions of individuals in the population, GS works surprisingly well with quite small population. For example, Axel uses only 20 individuals, and he success to evolve. And concern on what is represented in individuals' gene and the details of the evolution process. Sorry. There are some possibility to represent chromosome. The information of chromosome written in real number or alternatives. Real number or computer programs. It is a classical genetic algorithm. First, real numbers as gene. Ordinary real numbers rather than binary string. More efficient to construct since the binary coding is skipped. Mutation. Small random number added to a small how to mutate a small random number added to a small portion of genes. In classical GA, flipping bit will be used. And in classical GA, controlling programs are always the same, although the parameter values change.
Optical crossover in the real number case.
Crossover in real number case.
Yes.
It's not depend on maybe whether binary or real number. I think. Crossover.
Yes.
Crossover makes the chromosome only just cut and combine. So I think it's not
That's a decimal digit.
sorry.
10進にして桁を切るという。
いや染色体のリアルナンバーってこれを実数にするっていいなと思ってるんですけど、それを実数にしてもクロスオーバーは切る場所を決めて切った場所でくっつけるっていう作業だからいけるんじゃないかなと思ってたんですけど。
Maybe using real number, maybe this is only binary area, but using real number to making some extend spans or
そのやり方じゃないと思う。実数値 GA のやり方はどっかに書いてあるはず。小野先生がやってますよ。
これを一回、バイナリに直す。
いや、バイナリには直さないでやるんだよ。バイナリに直したらだって余計時間かかっちゃう。でもっと言っていいですか、
はい、
実数値なのになんで整数値でやってるんですよ。
イメージです。
イメージになんないじゃない。 0. 点何ぼとかってさ、
はい、
123.5 とかさ、その辺をどう交差させましょうかっていう今は小野先生やってるんだけどさみんな納得してるけど分かってないだろそれするって
ただ今あんまし書いてない気がします。
書いてなかったらどうするの？
調べる。
そうですよね。実数値 GA をちょっと調べてこないとダメだね。誰か使うかもよその辺は、だって01に直してたらバカバカしいからね。ちなみに突然変異はどうするの？
突然変異はこれです。
だから
なんだっけなんか積分布みたいなので積化したなんかみたいのを足すだか引くだかかなちょっとあんましちゃんとは覚えてないです。なんかそのようなことが書いてあった気が。
F の数も大丈夫ですか？
スタンダード
入るでしょ。
デリエーション。
平均ゼロの正規分布から取るんだよね。
はい。
標準偏差がパラメーター内だよね。
クエーションの中のパラメータの表示の差似ている。
There is a range, right?
はい。
Maybe that there are many properties, and properties have a real number variable, a value. So there is a range. So using the standard その標準偏差を使って平均ゼロでやればあ、じゃあ標準平均ゼロか。
平均ゼロ。ゼロミン。
ゼロだよね。で標準偏差がレンジで取ってくれば乱数、その後の乱数を足せば突然変になるでしょ。
これだけですか？他の方法とかない？
実数値の場合はそれをやるって言ってる。突然変異をするにはね、01に直して10入れ替えたらこばかしいから。
まあ、他の部分のなんかを足すというのはない。
他の分布足しちゃうとレンジから超えちゃうじゃん。
ああ。
Programs. In classical GA, controlling programs are always the same, although the parameter values change. So in genetic programming, different from classical GA, controlling programs of the agent are evolved directly as well by encoding the program itself, not just the parameters. And personal budgeting is an example. Evolving an agent that evolve the agent that can do personal budgeting. I think, ability to decide what to purchase from a regular income. And, first, the formula is a random combination of variables and operators in formula is random combination of variables and operators in correct syntax. Formula will be evolved by feeding new formula from the best performing population. So it changes program. How to calculate steps of evolutionary process. At the outset, from some representing a random formula is given to each agent. Random combination of variables and operators in correct syntax. Feed new formula from the best performed agent in the population by crossover or mutation. Eventually, the average performance will be improved. In this genetic programming, it is different from classical GA. And it has to crossover and mutation have to be designed to ensure the chromosome representation in correct syntax. So usually we use tree structure. Structure is this. And how to crossover and mutation is the chopping branch, and attaching, and mutation is exchanging operator or variable randomly. For example, plus, minus, okay, or variables randomly. Next, learning classifier system. Agent incorporated with production system. Set of condition action, rules and rule interpreter. It was introduced in chapter 8 today. Internal states of such agents are retained in working memory. Change line action and reaction to the environment but rules themselves are unchanged. Learning classifier system. In learning classifier system, agent can improve its rules by rules set by learning from feedback about its action. And there are two ways of interaction. One is the relative priorities of rules, this bucket bridge algorithm, and the other is rules evolve themselves using GA. First budget bridge gauge. あともうちょいです。ほんまじゃん。
だって説明がさ説明してねえもん。
あ、じゃあ流しますね。
逆になってるし。
この辺は分からない。
描写ツール。
他の範囲に助けを求めた。
うん。すごい。ちょっとよくわかんないです。スライドショー。左下の。Owners are related, especially how few don't care. はい、もういいですね。ちょっとわかんないです。And rules evolve using GA. Please see later. And ちょっとこの辺が
ルール自体が
止めるとかない
で、なんか進化させる。
読んでないんだな。
こういうのを防ぐためにルールを作るんです
で、
この人
This is evolution strategy. It doesn't use crossover. It was born in Berlin, 1860s.
それだけ言われても分かるわけないんで、ペアの人なんかしましょう。
In this strategy, we don't use crossover, but we only use mutation.
あ
This is just a random walk. Random walk. Genetic.
まあ、集団が大きな割合で突然変異を受けて、まあ、その中からランダムで選んでいく。
いや、ランダムだよ。
ランダムです。
すごい。
あ、いや、ランダムだって。
ランダムに変異。ランダムに。
まあいいや、飛ばします。
はい。
じゃあもう終わります。これがエボリューショナリープログラミング in page 252 and 53 state machine. It is used to control compilers or ATM. That's all.
Okay, basic question. Why mutation is needed? Can you
To
explain?
have divergence.
No, to abstract. To abstract. Why?
Sometimes the maximum position is not global maximum position in the process of GA, suboptimal position. And if there are no mutation and diversity, it will be so こうなっちゃう。It maybe keep this suboptimal position, but with some diversity, so mutation, some individual mutate, and it makes なんか全体的な最適解に近づくことができる。多様性があれば。多様性がないと局所的な最適解に落ち着いちゃうことが多いけど、多様性を持たせることでそれを防ぎます。
Do you understand?
But perhaps the mutation is has another function that we can by introducing mutation we can decrease the number of the population to generate a rather optimized solution for the question. If there is new mutation, we have to have a large number of initial parents to run the GA to get a better solution. We have a initial parents that if there is
Initial
no
generation.
if there is no mutation, we have to generate a better solution for the question. We have to have a rather large number of the initial parents to have the diversity. If we incorporated the mutation, we can reach the optimized solution with a rather small.
So if the mutation not exist,
Yeah.
the goal depends on the initial
Initial.
parameters.
Yes. And if we want to have a better solution, the number of the initial parameters will be very large. A lot, yeah. To have a divisor, we have to get many kinds of initial parents to generate the offsprings if there is new mutation.
日本語ですか。
すいません。変異がない場合で、なんか初期のなんていうか。
初期状態で
初期状態で。
そう
そう。で、なのでなんかスケールソリューションをなんていうか見つけ出すにはなんか、初期状態の数は非常に多くなる。
多分それもあると思います。ただ本には一応多様性をなんか途中の局所的最適解的なところに引っかかってもフィットネスがもう一回そこで止まらないようにみたいな感じで。
This is very, very important thing that you omit.
すいません。他になければおっしゃったけど。 終わりにしたいと思います。Thank you for your attention.
じゃあ遺伝的アルゴリズムとクラシファイアシステムの違いはいいの？出さなくていいよ。簡単だから。M1 が分かってればいいや。社会シミュレーションと遺伝的アルゴリズムがどうくっついなんでくっつくかはいいの？
は何ですか？ M1 に聞いてるんですか？
そう M1 聞いてね。M1 が分かってるんだと思う。ほらでさ、遺伝的アルゴリズムで何かがさ01のビットに変換されるのは分かる？まあ、例えば買う買わないだと01なんだけどさ、それに付随して条件とか次の桁数に01で入ってたりするんだけど、最初の一番右側のビット数が買う買わないだとすると、その前の条件で例えば10桁ぐらい使って000101000の1とか110戦略がいくつかはまってるわけよ。いろいろな条件を01で表現していくと何桁にも、例えば簡単にいくと10の条件があったとしたら10桁あるわけよ。それに10の組み合わせが入るわけ。それに最後01で買う買わないが入ってくるわけじゃない。それでさ、その評価するところとしては、買った時の例えば利得みたいなものを計算して満足できるか満足できないかって考えたとするでしょ。そうするとその10の中で満足できる10ビット数のやつらがあるわけじゃない。もしくは買わなくても満足できる回があるかもしれないけど、その中でだから満足するものを集めて、その最初の条件のところグイグイと途中で切ってまたガッチンコすると新しい戦略みたいな条件が生まれてくるでしょ。それ何回も繰り返していれば平均以上のものが出てくるはずじゃないのかっていうのが遺伝的アルゴリズムの基本的な考え方ね。だから何個か残った世代の最後のこの組み合わせとか突然変異を全部ガラガラやっていくと、なんか良さげな条件みたいなものが出てきそうじゃないかっていうのがその遺伝的アルゴリズムの考え方なので、ここのポイントは何かっていうと、その条件が変わらないのよ。10項目が変わらない、組み合わせの問題なだけであって条件自体は10個は変わってないわけで、最終的な買う買わないも変わらないところが遺伝的アルゴリズムなんだけど、そのをビット数ではなくて実数値でやったのが実数値 GA で、実数値 GA の場合の交差はどうするかっていうと、例えば簡単にいくと1と3っていうのがあったとしたら、1から3の一応乱数で交差させるのっていう方法があるのね。言ってることわかるかな。配列考えた方がいいんだけど、例えば3つの数字の配列を取ったとしたら、それぞれの1桁目の範囲で乱数を取るのが交差の方法なの、実数値 GA の。いろいろ何倍にしたりとかあるんだけど、方法は基本的な考え方としては数値と数字の間の乱数を取るのが実数値 GA の交差のやり方なの。だからさっき出てきた標準偏差、平均値0の標準偏差はそのレンジの中で取ったもので乱数を足しますよっていう、そういう概念があるからなのね。そこまでいい。でクラシファイアシステムは何かっていうと、その条件も変えちゃうのがクラシファイアシステムなのね。なんか勉強していくうちにこんな新たな条件あったらいいじゃねえかみたいな、簡単に言うと結合しちゃったりとかなんだけど、条件1条件3をなんかミックスして新しい条件考えた方が楽じゃねえかとか、もうそのものルール自体が変わってきちゃうのがクラシファイアシステムなのね。例えば3回目に3つ買うとか4つ買うとか5つ買うとかっていうので、どの条件が一番いいかなみたいなので一生懸命組み合わせて解いていくのが遺伝的アルゴリズムに対して、3回目に N 個買うっていう回だけがあって、 N 個を自分で一生懸命試行錯誤しながら決めていくのがクラシファイアシステムなのね。だからソワーズでクラシファイアシステムやるとすごい大変なことが起こるのね。やったことあるじゃん。あれはもう条件とか全部決まってるから、あそこのルール自体をもう勉強で変えてしまうのがクラシファイアシステムなのね。で一番簡単なのはだから物を買うときに N 個買うっていうのが面白いところで、 N 個をどうやって計算するかって自分で考えて条件付けからルールまで決めちゃうのがクラシファイアシステムで、遺伝的アルゴリズムだと多分1から10の範囲の中で条件をうまく計算したのでガチャガチャ組み合わせて3個出すとっていうことをする。なので、学習は学習なんだけど、動的に変化したりしなかったりというところが変わってくるのがこの3つの。最後のやつは別に交差入ってない、ただ単に最初の値を乱数使って探しましょうねっていうやつなだけなので、交差が入ってない遺伝的アルゴリズムって考えれば一番いいと思います。 最後のやつは勝手に数値をさ乱数で変えていけばそのうちなんか当たるだろうっていうやつね、まあ、それは一番皆さんがやりそうなやつなんだけど、クラッシュファイヤーはやってくれると嬉しいけど、やりできそうなのはワン君とかかな、研究とテーマ的には。だからいつ変革をもたらいつ革命をするかっていうところで、エージェント自体にもそのいつっていうところを学習させちゃう。何回も何回も試していって。
そうですね。
それはそうでしょ。1000回2000回やればさ計算効いてくるわけじゃん。ルール変えながらね。ダメだったらルールを条件を緩和するとかさ、一生懸命そういうふうにセットするんだけど、それ多分人間より強い戦略が生まれるんだよ。
今の仮説でしたら一番でかいやつを選ぶというのがあって、 GA でしたら
でかいやつを選ぶだとどのタイミングで選ぶかを GA で解けばいいんだけど、クラッシュファイヤーの場合はいつどこでどのくらいの大きさまで全部やるんだよ。そういうふうにプログラムする。だから最初は1回目の1個目小さい値から始めてどんどんやりつつ N 回目のヒュージデータみたいなことが出てくるとクラッシュファイヤーシステム。この辺マナハンがいるとめっちゃ説明するんだと思います。っていう補足でした。
ありがとうございました。
大丈夫でしょうか。
ご理解いただけたでしょうか。
わかんねえんだったらグループで解決してこいよちょっと。
はい、
実数値 GA なんていっぱいネットに転がってるぞ。
ウキでも
簡単ででもいいんだから。
そうなんかサンプル出した方が分かりやすいんだと思う。
もう教科書そのままやらなくていい。教科書時代来るから。
難しくね全然概念書いてあるんだから当てはめるだけだよ。
スライドを書いていいですか、僕の方に。ちょっとゼミのそのチェアとかをこれから先決めたくて、それでこの前ドクターの方に言ったんですけど、一回そのスライド落としてもらっていいですか。スライド落とすっていうか、
そっちのリモコンで操作する。
ワイヤレスを
自分のところでリモコン操作する。
なんか他のユーザーに使用されてますってなって、
リモコン出ない。
これ終了しちゃえばいいかな。
切り替えちゃえばいいじゃん。